All right, and in our final three videos here, we're going to be working on this handout right here, modeling with functions in section 2.6. So I've broken it down into three different videos. In the first video, we're going to talk about um, how we state something in words and how do we write that as a function. So when we say write the area of a circle as a function of the radius, we're really filling in, we can write some value as a function of another value. So in this case, I've underlined in red where it says express or write as a function, write something as a function of something else. Now, when you see that write something as a function of something else, this part right here, the first part of your statement, is your output of your function. So your output is your range values here. What values come out of the function. You're going to put into the function the values that are at the end of the statement, which are the radiuses. The radii in this case, that's your input. These are also called the independent variable. So the input is the independent variable and the output is the dependent variable. Now when we're writing this out, this is going to be what is on the first part of your formula. So area, in this case we would write that A is a function of its radius. So area is equal to something function in terms of the radius. In this case, the area of a circle is pi times radius squared. So that's our function. Area is pi times radius squared, and it's written as area as a function of the radius. Now the domain of a function is always the input values. So the domain of this function would be these values here. So that's going to be the radius is the domain. Now if you're dealing with real world situations, which we would be dealing with here, is that the radius is going to be greater than or equal to 0. And in this case, we would probably just say the radius is greater than 0, because having a radius of 0 would mean that we have no area. So we would probably put the radius is greater than 0 here, so that we'd have a value coming out of the answer. But in this case, we probably could also say that the radius is greater than or equal to 0. 0 would give you an answer. All right, in the second function, it says the length of the rectangle is 3 times its width. Express the perimeter of a rectangle as a function of its width. So in this case, we're going to have to do some work with the expression. So we're going to express, the expression is going to be the perimeter is of a rectangle. So perimeter of a rectangle by formula is 2 times the lengths and 2 widths. But in this case, there's another part of this that says the length is 3 times the width. So we're going to use this section to help us modify our relationship. So if we know that the length is the 3 times the width, that's not going to be our perimeter formula, but we know that 3 widths is a length, so that means that this value right here, the length, in the perimeter formula can be replaced with 3 widths. So in our perimeter formula, we would rewrite it so that we can have our perimeter in terms of just widths. So we have 2 times R3W plus 2W. So in this case, perimeter is going to equal 8W, 8 widths. Okay, and our domain in this function would be the width, so that's going to be greater than 0, and our range is perimeter, which is also going to be greater than 0. All right, in our third example, we have a box. It says find the volume of the box. So the first thing we would do is we would find a volume formula for this case a box, and the formula is L times W times H, which is length, width, and height. We would then go back to this picture and identify the length, width, and height as 6 feet times the width, 2 feet, times the height, 3 feet. So our volume is going to be 6 times 2, 12, times 3 is 36. So our volume is going to be 36. And since each of these units is a foot, 6 feet, 2 feet, 3 feet, this would be 36 feet cubed, or cubic feet, because we're dealing with how many little cubes can fit into this box. And 6 cubes can go this way, 2 can go that way, so you have 12 on the bottom, and then you have 3 going up, so that's going to give you 36 total cubic feet. All right, and then our final question on this one is finding the surface area of the box. The surface area is basically the area of every surface. So we have 2 sides, front and back. We have 2 left and right, and we have 2 up top and bottom. So we're going to have 6 surfaces here. 6 surfaces. Oops. So our 6 surfaces are going to have areas. So some of them are going to be similar. So the right and left surfaces are going to be the same. So our surface area here is going to be 2 times, let's say we're doing this surface, 2 of these surfaces. That's 2 times 3 times 2. The area of that is length times width. They're all rectangles. 2 of that surface. Okay, and then we're going to have 2 of the tops and the bottoms. So if we look at this surface, that dimension is 2 feet by 6 feet. So we're going to have 2 of these also. 2 times 6 is its dimension. So 2 of those surfaces. Each of our surfaces is in a rectangle, so each surface is going to have a length and a width. Length times width, because it's a rectangle. And then we have this surface here, and there's 2 of these as well. So this surface is 6 by 3, so we're going to have 2 of those as well. So 2 of the areas of 6 times 3. So if we compute this out, we use our calculator. Let's see, turn it on. So we have 2 times 6 plus 2 times 12 plus 2 times 18. We get 72. So we're going to have 72 as our answer here. And then, so 72. In this case, we need to look at units here. So a surface has a length and a width. So each surface has a length and width, and these are feet. So it's feet times feet here. So it's feet squared for the area. Plus, you're thinking of little boxes, not boxes, but little squares on each of these. How many little squares we'd have here? On this surface, we'd have 6 going this way and 3 going this way, so there'd be 18 little squares on this surface. And that's where we get to 6 times 3. And then this surface, we'd have 2 squares going this way and 6 going that way. That's where we get 12 squares. That's this one right here. And this one's 2 pi 3. That's going to give us the 6 squares there. Each of those having 2 surfaces similar, and we get the same answer as we did before. So that's what the first part of this worksheet covers. Covers writing some output as a function of an input. And sometimes in doing so, we have to use a relationship. There's a relationship. So in some statements there's no relationship other than writing the function or writing a variable as a function of another variable. Or if they ask you to do a relationship, you may need to do a substitution to get the volume or perimeter.